Hey there, thanks for listening in, and welcome to another Ellipsis Drive podcast. Here we dive into the stories of people, companies, and technologies that transform and empower spatial data-driven industries. My name is Rosalie van der Maas, and today we talk about the tricky road of spatial data mastery in the field of property and casualty reinsurance and climate risk. To dig into this topic, we have two guests with us today, calling in from the Boston area and Singapore. So with me calling in from Amsterdam, we're doing some serious time zone gymnastics. But in any case, Todd, Randy, a warm welcome to you both. Todd, good to have you. Could you perhaps, yeah, sure thing. Could you perhaps start us off by telling a bit about yourself and your work?
So my name's Todd Barr. I'm the Director of Geospatial Solutions and Products at Verisk Extreme Event Solutions. I've been working in the insurance industry for a little over 4 years. Before that, I've been in geospatial for over 20. Most of that time was in the defense and intelligence community. And then I kind of fell into insurance randomly in 2019. So it's been a fun ride because I started working at Verisk about 2 months before the pandemic hit. So it was a very interesting time to try to get started. But I'm finding the data problems in insurance are some of the most fun I've ever solved. So I love the vertical.
So you're staying a while?
Probably.
All right, good. Thanks for that. Randy, same for you. Quick intro would be great.
Yeah, thanks, Rose. So I've been with SCOR Ventures for the last 2.5 years, looking primarily after the ventures investment activities we have in the APAC region. And prior to joining Ventures, I work in the CAD modeling space for a little over 20 years. I've been with insurers, reinsurers, and brokers in my career. And because of this background, so in my current role, I do get more involved with climate and geospatial analytics startups globally also. In terms of generating deal flow, due diligence, and connecting solution providers to the SCOR business operations. I think that's also how I met you, Rose.
Yeah, that's right. And it's good to have you both here. Like, clearly a lot of experience on the geospatial side of things, a lot of experience on the insurance side of things, and indeed, a good position to comment on new technologies there. So perhaps we can start off easy considering the topic today. Randy, could you explain a bit more about the exact role that reinsurance, specifically like property and casualty reinsurance, plays in the world? Like, why does the industry matter?
Yeah. So I think the insurance reinsurance industry has always had a key role to play in terms of financing protection against many different forms of risk, right, for the society. And natural catastrophe risk is one of them. And so for the last 30 years now, insurers and reinsurers have been using CAD models, stochastic CAD models in particular, to price, to underwrite, and also manage our portfolios. In the last 10 years, we started to see more of the impact from climate change. Losses caused by weather perils are definitely occurring with higher frequency and increased severity. And that is really challenging the models we use today. We hope, and I'm quite interested also to hear Todd's view on this, but we hope lots of the new geospatial data that's becoming available now with better satellite images and technologies like sensors and devices can be used to help the CAD models better account for climate risk.
Okay, so you've actually really noticed on your bottom line and throughout operations that new conditions climate-wise are challenging the models that you have. So things do need to change for the better in order to handle that risk towards the future.
Yeah. That's how we feel about it.
Okay.
Yeah. And you just need to look back to last October with Otis, right? When Otis hit Guadalajara or Acapulco. I went to bed. I was in Baltimore at the Free and Open Source for Geospatial conference. And when I went to bed, I think it was a Cat 1. And when I woke up the next morning, it was a Cat 5. Right? It went from 0 to 5 in less than 12 hours, or 1 to 5 in less than 12 hours. And I went looking through our 100K catalog, which is 100,000 years of hurricanes. That's all synthetic, right? Not real. Like you're talking about, it's a stochastic catalog. But I couldn't find anyone that did it that fast. So we couldn't model Otis even if we tried using previous methods, right? And that's just one sign. It's happening in California right now with the atmospheric rivers. What happened in Germany in 22 with all the flooding there. We're seeing major impacts from different perils across the globe affecting our bottom lines.
And a bunch of that you would consider like on models events or things that your models would just not show you.
Normally the models would have something that was similar, right? Because it's an SSE is a similar stochastic event, and it's not exactly what's going to happen, but we've modeled a lot. Here's kind of with these parameters, here's what's probably going to happen.
So on the topic of models, could you, if we take a step back, could you shine a light on why we're modeling things and what sort of things are being modeled in this industry, just to create that baseline?
What isn't being modeled? Randy, you want to take this? I can hop it up.
Go ahead. Maybe I can fill in.
Okay.
Later. Yeah.
So from Veris' perspective, we modeled major perils: wildfire, flood, hurricane, windstorm, and our latest one is like cyber, right? We have other companies within Veris that model other risks, like our Veris Maplecroft. They model political risk. They model. They have this one thing they just released. I love the name of it. It's strikes, rebellion, and civil commotion. Right? Like, where is there uprising? Where is it people? They also do a bunch of climate change stuff, like where would a reduction in water cause political instability. So really, we model almost a number of different risks. From a geospatial perspective, I used to think the only risk that didn't have a map was cyber, right? Because you can say a data center in Virginia is being attacked, but it really doesn't matter in space. And then this last weekend, I read an article that some scientists, I can send you this afterwards. You can put the links on this podcast, where they use geospatial analyses to determine the effects of a cyber attack. Because it's not necessarily, as these XY coordinates, but how it kind of flows out through Tobin's law, closer things are more like, and how we can better model cyber attacks by using geospatial analytics. Yeah.
So that's super interesting. Because I was asking the question because I've always find it interesting to sort of understand the difference in, skills you need to bring to the table to model something that is spatial, or to step up your game when it comes to modeling certain phenomena and do better. Like, for example, this cyber example is great in that matter. Like that, initially you may not think it's geospatial, but when you do actually start to take the geospatial elements into account, you do a better job of modeling it regardless. So how do you see that? Or what would you say if you sort of double click on that general interest, like modeling spatial things versus modeling things that are not spatial?
So most of the stuff I model it's spatial, right? So, and I was saying, the only reason I picked up this article is because it said it's using geospatial techniques to model cyber events, and to build a stochastic catalog around by using these geospatial analytics. So really, at this point, in my opinion, there's no non-spatial peril.
Randy, would you agree?
Yeah, I very much agree with that. Even for cyber risk, we have to know where the attacks, where the targets are, because the local market and the local environment also has a effect on the final losses. So I think to have kind of the notion of where the risk or the exposure is located, that's critical. Yeah.
And one more question on the topic of modeling specifically. What are the different needs when it comes to modeling for insurance and modeling for reinsurance? Because reinsurance is in that sense like an insurance for the insurance. But what does that extra layer do to the analytics that need to feed into your process of risk management?
Yeah, maybe I can, give it a go first, and then hear what Todd has to say about this as well. But I think direct insurance typically requires a high resolution because for direct, each policy is one location. So, to get the risk right, the model has to be very precise. So that requires a very high resolution. For reinsurance, on the other hand, each policy basically covers one whole portfolio for the direct insurer. And then that's made of, millions of locations in this portfolio. So this allows you to have, I guess, more margin for error, because we, at the end of the day, really just need one loss distribution, one loss curve for each of the reinsurance contract. So I think there's a difference in terms of resolution that's required. And then I guess another difference I can think of is direct insurance policies. They typically sit in one country, whereas reinsurance portfolios tend to be more global, with exposures from many, many different countries. So we, for reinsurers, we need to have a wider model coverage to help us, model all sorts of different perils globally, so we're not missing out the risk for reinsurers portfolio. Yeah. Anything you would add to this?
No, I think that's really solid. Because reinsurers aggregate it all to a higher level, right? So they're like at a 50,000 foot view, and insurers need almost like a millimeter view or a centimeter view, right, to get the exact, and especially underwriters. I like it when I get approached by an insurtech startup who has some sort of like new LiDAR technology or new SAR something or rather, and reinsurers will be interested in this because we can get down to sub centimeter accuracy or sub meter accuracy. I'm like, no, you're after insurers and underwriters, and reinsurers, a kilometer level is fine for a reinsurer, right? If you get as long as you're in the ballpark, they're okay with it because all their analytics are aggregated to the point where if it's a few meters off, they're not going to care, right? But like an underwriter, even when the FEMA floodplain moves, an underwriter can, risk it to expand exponentially if a FEMA floodplain moves 50 meters left or right. A building that wasn't in a floodplain suddenly is, and that just, increases their risk by a factor of 5 or 10.
So what does that mean in terms of the challenges around spatial data management? Because this is quite interesting from indeed an analytics type view, what sort of aggregation level is relevant for your business. But what does that mean for spatial data management? It sounds like for reinsurers, life may be easier because they don't care about that millimeter view due to the type of business that they run. But at the same time, they are interested in significantly more data, seeing as it's not just about a specific region or not just about a specific country. It's basically global from the get-go. So what are the repercussions of that?
Yeah, I think in actual practice, so even though I said earlier, reinsurers don't require as high of a resolution in the modeling as the direct insurers, actually we get the high resolution modeling results and exposure data from direct insurers, right, who are placing their reinsurance business with us. So the sheer volume of data reinsurers have to deal with, having to store and manage, is hundreds of times more than direct insurers typically. So the storage, we have to have a secure place for that. For the data we receive, we need to have the capability that's robust enough to process the data and also run the models. And then when we're done running the models, the results are also very high resolution. We have to have a place to store that as well, and pump that into our pricing and underwriting engines. So yeah, data management is very key for reinsurers, and because again, our portfolios are global, so we also have to respect the various local data laws and regulations to make sure we're in compliance with that. And then on top of it, to do kind of, the pricing, underwriting, or any further analysis with the modeling results, then we have really a pretty, large number of tools to help us process that and analyze to create more intelligence for us to understand, and also keep track of the events that may be happening across the world. So mapping software, SQL databases, Power BI, you name it, we'll probably have someone on the team using it somewhere in the world. That it creates a lot of work for us from a management standpoint to make sure we not only are able to process it, but we have a governance structure around that as well, and the teams are able to share with each other pretty much real time, because our modelers sitting in different offices are probably working together on the event response or studies to better understand the models. So the whole kind of the requirement on the system affects how we work in a major way. And I haven't really gone into all of these new geospatial data we're seeing that's becoming available to us. So just kind of the standard exposure policy data with simple characteristics about the risk, spatially, is already terabytes of data that we're having to manage.
Yeah, that sounds like a real operation.
Yeah, and the size of the data is not going down either, right? It's just there's going to be more and more of it.
I think it's death, taxes, and data grows are the certainties in life. Yeah. So Todd, how do you see that from where you're sitting?
So Randy's pretty spot on with the fact that we do get hyper detailed data to start with, but we aggregate it up to a kilometer level just because that's the minimum amount that our clients really do or use. But what one of our big data challenges is our models have iterations, right? We have version 1, version 2, version 9, version 12. And each of those, there's slight differences in those that could throw off an entire analysis. So depending on, sometimes we get a call from a client and their analysis aren't jiving up. It's like, well, what version of the models are you using? So understanding what version of the models they're using kind of drives their analytics. So if they're not using the same version of the model, there's obviously going to be a difference because, FEMA floodplains could have changed and it's a flood model, right? So this is a little different. So managing that both internally and externally becomes hard. It's just a matter of, obviously you just have to communicate a lot with your clients about it. So they have an understanding of what you're doing or what system they're running on and what version they're running on and what their analysis is doing. So that's really one of the big data management issues we have, is just making sure everybody's on the right version, right? And as Veris moves into the cloud, that won't be as big of an issue as is right now. Because right now, our flagship product is still installable, right? It's installed on desktops or locally or in our private cloud. It doesn't move to Amazon, that'll change.
Okay. All right. Yeah, it sounds so simple, version management. But indeed, when you have your operations outside of the cloud, that can be a real challenge. Yeah. What do you think after versioning or after your cloud migration, say, would still stick around as something that would be a hairy problem?
Discovery. And I think every organization has that. When I used to work intelligence, I always used to say the safest place to hide anything was on a SharePoint site, right? No one could ever find it there. Might as well be in if it's not a SharePoint site, might as well be in a SCIF. No one's going to find it. But we need to really, as a insurance community, we need to get together and figure out how to really leverage the tools we have for enterprise level search and being able to go through and understand what data we have internally and how our clients can merge our data with other data they generate or from our competitors, right? There's other methodologies to do that. It's just more data we're going to generate from that, right? And we already have enough, or we have a lot. So it's a problem that internally we're approaching. But again, insurance is a 400-year-old industry, and they didn't need this 300 years ago. So why do we need it now, right?
Yeah, I hear you. And I think it's interesting that the searchability, findability, or discoverability of data, whatever you want to call it, is as big of a problem that I indeed find that companies who are technically competing with one another are still very much happy to work together to solve that issue. It's like, yeah, it's worth it. Even though you have to go through one door, it's very much preferred. So yeah, it's interesting that you also highlight that here. So basically we find that it is important to have that comprehensive view of the geographic context in which risks are embedded in order to be able to manage those. And we have consensus on exposure data being spatial in nature. So that means when it comes to spatial data mastery, improving on that scale does have an effect on running the operations better in terms of pricing, underwriting, and claims management. What can this mastery look like? Or if I turn it around, where is it clearly lacking today? And then this may be a difficult question, but it gets to the meat of it. Who would take a stab at that question?
Maybe, I think one thing I like to point out first with regards to exposure data in general is if we break it down, we have to, we think about our exposure data in terms of at least two aspects. One is, the geospatial characteristics of the buildings or the risk wherever they are. But the other half is actually the policy data. And insurance policy data sit in these huge legacy system for insurers and reinsurers. And it's really not a trivial exercise for insurers to attach geospatial characteristics to the policy data, simply because they sit in different systems. At the same time, geospatial data are useless unless you attach them to policy data, for insurance purposes, for pricing, underwriting, and also claims. So that is, one huge task already. We think about having to integrate these systems. If you don't, then you got to figure out a way basically to stitch together your insurance policy with geospatial, number one. And then the second thing, I would say, again, is on these pricing, underwriting engine, or even claims process for insurers. They've also been around for quite some time now. A lot of these engines are Excel-based. So with the existing CAD models and the modeling results we have, we already having to sort of figure out ways to ingest modeling results, modeling curves into these somewhat dated pricing underwriting engines and also claims process. I think that's going to get even more difficult when we think about new satellite images, aerial data, sensor data, and how we plug these data into the existing insurance underwriting and pricing engines. I mean, those are kind of the things that really jump to my mind in actual practice when we talk about kind of the whole spatial data mastery, like the hurdles that we have to get over today.
Mm-hmm. Yeah, because a lot of times it feels like I'm hooking up, an Xbox to a black and white television.
Exactly.
It's like, wow. we have this really high speed stuff, and it's going through an Excel spreadsheet. Okay.
Yeah.
One of the things I found really interesting when I came to insurance was I always saw the importance of geocoding, but insurance, it's all about the geocode, right? It's, on top of the building, because if it's, if you have a facility like an oil refinery or something, it has an address, but that oil refinery could cover 2 or 3 different areas and could be in different wind zones or different inundation zones. So how do we insure against that, or how do we judge that loss, right? It's just I always found, and as we get deeper into it, geocoders are becoming, they're more accurate as we move forward. But it's just, I don't know, I never thought of the importance of geocoding until I was really here. Even I was working in oil and gas or even in defense, it's like, we have a general area, but this is like, we want rooftop. And especially as we go into more like AI-based things, using satellite imagery and aerial imagery to determine roof loss and other damage, that becomes more important.
So you would say, when asked what level of spatial data mastery would make a difference, you would also point at geocoding specifically?
Yes. Geocoding is 50% science, 50% art as it is. But when you actually create a geocoder that can get rooftop or campus level geocoding, that's next level. Randy, I don't know if you're familiar, but they've taken the entire world and done 10 by 10 meter squares, and each square has 3 words. That doesn't describe it. It's just where it is. Like, if you look, like, I lived at one place that was like a shovel something tree, right? And that square meter, that block on the planet. So it's just a different way to do that long, but it's just easier to remember.
Yeah, and it's so simple, and yet it is nice to project a situation in which that would be the standard on the way we're currently living. It's like it doesn't actually work because of legacy and a myriad of other things, but it's still a nice what if scenario.
It's fun.
Yeah. Okay. So we already touched on data discoverability a bit. Something I was wondering about, like, are you guys in a position where, like, biting your nails, being annoyed by, like, insights that you feel are technically available to you, but that are out of reach because data isn't discoverable, or data can be analyzed in conjunction with one another, or a spatial element sort of got lost along the way. Can I get some comment on whether that's an experience that you have, and if so, where do you feel like you're missing insights that are technically there and yet out of your reach?
So a lot of it, I'm going to go to I was recently doing an internal greenhouse project, which is our internal incubator for parametric books. Parametric insurance is where if you happen to, like, when you're developing the insurance contract, if you're in a certain wind zone, you get a certain percent payout, or inundation zone, right? So it kind of takes the auditor out of the process. So let's say your $1 billion exposure was in a 75% wind zone, let's say 130 miles an hour. You could pay that out, and then you just say, okay, then you get $750 million, the 75% payout, right? But to do that at scale, you're looking at, like a couple million locations, and then each one of those you have to build a buffer around for the various payouts, right? And to do that just off the metal on a database took hours. But I was using a GPU. I wanted to use a GPU-based database to make that happen, and we did it in seconds, right? Because that's the way the nature of the beast. But it's so difficult to get the insurance community in general to adopt new technology, because something could change when they change. Even jumping from like one database system to another, that could possibly change how the model is run, or something happens to it that changes the overall risk. So there's a natural, I don't want to call it an aversion, but it's a natural pause to see what happens with new technologies that are introduced. And I come in like, hey, we should use the GPU stuff. It's awesome. And everybody's like, we're not so sure about that because it could change things. Insurers like the consistency of certain, because they understand, there's billions of dollars are at risk. So they don't want like a line of SQL code changing everything, right? So there is that natural, like, oh, we have all this neat, cool stuff we could use, but that's not the culture of insurance. It will be adopted over time as people test it, and they go through different testing cycles and understand the impacts of what could possibly have on their books or other things. So a lot of times it's like the answer is here, but there's a cultural blocker to get there. Does that make sense?
Definitely. I think, Randy, you may be in a perfect position, like considering what you do, to comment on this as well.
Well, I think it's really interesting what Todd mentioned, because that's one of the many ironics about the insurance industry. We don't necessarily like changes, but the world today is changing all the time. And climate change is one of the many things we are very concerned, very worried about currently. So we know it's changing. We see the losses coming in, yet we are not always so comfortable or good at finding ways to adopt new things, meaning change. But in this case, we must. So, when it comes to climate, we're struggling a bit with the existing models we have today to account for the impact of climate change. And I'm talking just the physical risk. We don't even, think about transition risk so much yet. But yeah, we're seeing the losses probably induced a lot by climate change already. And we're having to underwrite somewhat differently today. But we're seeing climate impact in the new geospatial data, right? We're collecting, but it's not reflected in the models. So this is something we would really like to see, us or the modeling space at least to figure out a way to plug or integrate, new data, new analytics that's being generated into the modeling framework. Because, we need to have, I think, a better or more robust view of the climate risk. as an industry, in order to price it, underwrite, and manage our portfolio against that. So that's definitely, one of the biggest issues that we want to address, but we're not so good at addressing it today with the existing tools.
So your first concern, rather than being able to find the insights that you would guess are somewhere in the data that it's available to you, but rather getting that connected into models in the first place, is the primary concern.
Yeah, I mean, insight to climate, which is pretty abstract, obviously, but if I break it down, right, the insight to climate impact, to each of the local perils we're modeling. And that's what the CAT models do.
All right. Okay.
Yeah.
Interesting.
But CAT models, and Randy, I'm sure Randy's well aware of this, but CAT models are built on historic data, right? We build these models off, we've had these 25 hurricanes we built this model off or whatever, or 25 years of hurricanes. And now with climate change, we don't have that data. We don't have a historic thing we can point to go, this is what happened, right? This is how it's going, and this is, if you add this, what's going to happen, or what's the increase in wildfires? Why are there so many wildfires in Chile right now because of XYZ? We haven't been able to model that.
So what's the antidote to this situation of a lack of data that is representative of the future?
AI. Having AI, and I'm going to go completely off base here because this is my theory.
Go for it.
This is not representative of my employer. This is beyond. I think we're beyond the point where we have enough brain power in the relative companies to understand this. And I think we have to bring AI into this process, help build the synthetic data and run the test faster and simulate faster than we have in the past. Because Randy's aware of this, we are in a crisis. And we're not going to be able to get the CAT models up to speed and using the same techniques we did last time, right? We don't have that much time. This has happened quickly. Just to understand our risk and understand our exposures, understand the damage that could possibly happen, right? And it needs to happen at the speed of an electron, at the speed of human thought. So I believe it's going to require us interacting with using an AI assisted or AI boosted people to make this thing happen.
Do you guys already see yourself creating a digital twin of the real world with the models that you guys have today, or going into the future?
We're working on digital twins to a certain extent. We have a lot of building information, but we just don't. We're starting to put things together. We haven't really started down that path yet, though.
Okay.
But from an exposure perspective, we're more from an exposure perspective, less than an event.
Well, I guess let me ask that question a little differently. So the existing CAT models that we have today, they don't operate like digital twin because it's not real time.
Yeah.
So is that something? Do you see that's where CAT models are headed?
Yes.
Would that make sense for the models? Okay.
Yeah. Having an AI that generates instead of us building 2 months of building data, have an AI build on the fly. There's a company you might be interested in out of Vancouver called Tonka, Tanka. They do AI wildfire stuff, mostly for Cal Fire.
Yeah.
And we took a long look at their technology a couple of years back. So
cool. Yeah, that makes a lot of sense.
Yeah.
Would that method of modeling also make it easier to indeed start accounting for climate change in your models? Would that paradigm change be helpful?
It could adapt faster. It could fail faster, is what I should say. This didn't match what happened. So what the parameters we need to change?
Interesting.
Yeah, and that's probably gonna take some time for the insurance industry to get comfortable with.
I understood that we didn't have that time, but there's the other
That's why I say it's ironic. Yeah.
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 But I did say at a conference last year that I believe that reinsurance is going to be what saves us from climate change before anything else does. Because it's not about political will. It's about market value. It's about it's about the market, right? It doesn't matter who's president and prime minister. A reinsurer is looking at 2080 going, I don't want to rebuild Miami. What can we do to help stop that? Right?
Yeah. Yeah.
Well, so you can put that on your to-do list, Randy.
Save Miami.
Yeah. All right. Yeah. So, I appreciate that tangent, by the way, Todd. I'm glad we went down that road. No, seriously. Yeah. So, I had another question I wanted to toss in, and that's around data visualization. Because of course, data visualization is a thing. It's helpful for a lot of things, from better monitoring and deeper understanding to better communication. But visualizing geospatial data is, of course, all about projecting things onto a map. Are there specific challenges around this right now that come to mind when indeed we hold this against the light of spatial data mastery? So what are visualization challenges that you're running into? Perhaps I can ask this to Randy first.
Yeah, I mean, interesting topic. And Todd already mentioned geocoding earlier. I think that's really kind of the key foundation to what we do with geospatial data. We have to make sure that they're geocoded right. Otherwise, they don't make sense. But when it comes to visualization, I think the number of tools that we have available to deal with the number of types of data itself is a challenge for us to manage as a company. There's so many different GIS software, and now we have more and more new software to help us see the data, visualize it. So from a reporting standpoint, making sure that there's consistency, that's a challenge we're having to deal with. And I think, again, the new geospatial data that's becoming available, don't necessarily tell us the same thing. A lot of it is actually telling us something different from what we're getting out of the models we have today. So in terms of kind of consistency and making sure the results are integrated well, there's a lot of challenges and gaps. In what we're getting out of the different data sets. This is what we're having to deal with for the most part today.
Todd, what's your take on this?
So, visualizing the stuff on a map isn't difficult, right? Even at scale, we can aggregate up to a certain level. It's learning new methodologies on how to run your analytics, because there's a lot of what we do in the touch of geospatial modules. We have two methods. One's our grid, where you have circles of a certain size to determine your total exposure in that area. The other thing we have is more of a dynamic thing, where the application searches for the most exposure, right? It puts in multiple buffers basically to find where the most exposures are. I feel like there can be more done from an analytics perspective than just concentric circles, right? As we're starting to look into more diverse data sets beyond just raster and just, whatever the various data we're going to be using for things. We could use, web, the spider lines, other sorts of other sorts of geospatial analytic methodologies to make things happen, right? And maybe open up different aspects of the data. But right now, the insurance industry generally seems to be stuck in like, we're going to draw circles around this, right? And that's fine. That's how they've done it for forever. If you go back to like how geospatial risk was originally analyzed with pushpin maps, right? We have 1,000 exposures in Los Angeles. We need more exposures in Cleveland to balance those out. And they put pins in a map, and we're light years beyond that. But I feel like we're not leveraging as much through visualization as we could.
Would you know why that is?
I feel like it's a training thing. That's how people have always done it, right? And this is what people are asking for. And if you do something, you kind of deviate from the norm, it's not really well accepted right out of the gate. It has to prove its validity. It has to prove its value. And I think a lot of people, that does take a lot of energy and a lot of emotional energy to push up the hill. So,
yeah, I very much agree with that. I think also has to do with, again, the existing pricing, underwriting, claims process that people have already set up, probably not able to, accommodate or work with, the new visualization, the new way we're presenting geospatial data. So if the pricers are not able to do the same thing, factor that information into the pricing, basically, they're not going to look very good. And then vice versa, you have to be able to explain the pricing, right? And not just kind of point it to the map. That's where the risk is. This is what we know, but it's not in our pricing. It's that just wouldn't be accepted.
Yeah, that makes sense. Considering the time, I'm going to move to our last question because we can talk about this for hours quite clearly, but we can't. At the same time, we can't. We could, but we can't. So let me ask you guys, what's ahead for 2024? Like for the rest of this year, what's on your personal agenda in terms of the projects that you're kicking off at work, or what's ahead for your company? Let's take a peek at that. Randy, could you perhaps comment on this?
Yeah. So climate. This is a high priority for us. As a reinsurer, and climate is a global phenomenon. We're feeling the impact. We're looking for ways to better address, and we do see new data and tech is something we want to leverage to help us address climate risk on a worldwide basis. So that's a bit of an initiative that we have going on at SCOR, wanting to find ways and also collaborate, with the likes of Verisk/AIR and you guys at the Ellipsis Drive, for us to sort of find out ways to explore with the new data and tech, so that we can get a better handle on climate risk. And then we want to translate that into our pricing and underwriting, also how we manage our portfolio.
All right. So you'll get to that right after getting to just addressing the general climate change issue as Todd just queued up for you. All right. So that's great. Thank you. Todd, what's ahead for you in 2024?
Oh, way too much. So I'm a board member for the American Geographical Society, so I've got a lot of stuff around that going on. I'm a member of the Ethics for AI and Insurance Consortium, which is it's very interesting because I teach AI at Northeastern, and our first class is always on the ethics of AI. The big thing is this Geospatial Risk Summit I'm putting together for next January. because I've been to, I've been to Geospatial forever, and I was like, after North 51 last year in Banff, I was like, we should do a conference that's focused on geospatial and insurance, because insurance is spatially based, right? And we really don't have a community. We have a lot of the same problems, but we don't really talk to each other about it because we sit in our silos, our relative corporate silos. So I did what I usually do. I'm like, somebody should do that. And then I remembered that I'm somebody, so I should do that. And then I talked to some folks at a couple of conferences, and they thought it was a good idea. So I finally got the ball rolling at the beginning of this year for that. That's probably going to be the big thing this year. But from a professional standpoint, from a Veris standpoint, I recently taken over our Enterprise Exposure Manager project or product, which is large. It allows you to bring in all sorts of reinsurance treaties and run massive analytics against real-time events. So that's really just getting underway. We just launched at the end of Q3 of last year. So it's a product that will get there. And right now it's going well, and we got a bunch of positive feedback from clients. That's, from a Veris perspective, that's what I'm doing.
All right. So sounds like by the time Jan rolls around, there are lots of things to catch up on, and we should definitely do so after the event of yours kicks off. See how that went.
As soon as I find a venue.
All right. Great. So, with that, we are at time. On behalf of the listeners, I warmly thank both of you for sharing your stories here. And if you're tuning in and you'd like to know more, we will indeed leave links in the description so you can find the resources you're looking for. Thanks for being here with us today, and until the next one. Cheers.
All right.
Bye. Thanks very much, Rose.
Yeah, thanks, Rose.